Welcome back for the fourth part to our solving isosceles triangles video. It's the last one we're going to do. I want to focus on question number 5. So I've gone ahead and read the directions. Now this is a little different, guys, but they're still giving us the same information. Look, triangle BAD is isosceles with base BD. Now think about it. Remember, the base in an isosceles triangle is going to be the one that is different than the other two, which means if BD is the base, look guys, that makes AB and AD the legs, okay? Leg, leg, base, okay? You should really get in the habit of always labeling that, and as a matter of fact, always attached to the base will be our equal base angles. Remember, angle B has this leg across from it with the double dashes. Angle D also has a side across from it with the double dashes. That means these two angles must be equal. All right, here we go. Now they tell us the measure of angle A is 32x minus 8. So that's this one here, 32x minus 8. Guys, I'm going to make sure that I'm pointing that towards the inside so I don't forget that that's an angle measure. They also tell us that the measure of angle D is 16x plus 24. All right, now, at this point in time, I need to talk to you about a common mistake that students make here. A lot of times students just automatically think, oh, I have this, let me just set them equal. Incorrect. We don't know that these two angles are equal. We know that these two angles are equal. We'll come back to that. Another common mistake is students will take this plus this and set it equal to 180 degrees. That is impossible. Remember, it's all the sum of all three angles, and that's actually what we want to do here. If we don't know that these are equal, we need a different plan here. So one thing that I want you to make sure you understand is this. We have marked these two angles equal. So guess what? Whatever I have labeled for angle D is going to be the same for angle B. So I'm going to write 16x plus 24. I'm going to do it in red just so it stands out for us, okay? Now, ladies and gentlemen, we have 1, 2, 3 angles labeled. We can add them up and set them equal to 180. Now, I'm noticing I got some small space here, so I'm going to try to condense this a little bit, but I'm going to have 32x minus 8 plus 16x plus 24 plus 16x plus 24 equals 180 degrees. If you wanted to put 16x plus 24 in parentheses and a 2 out in front, right? So basically like 2 of these plus this equals 180. That's the same thing. All right, boys and girls, here we go. 32x plus 16x plus 16x, that's going to be 64x. Okay? Then we have 24, that's 48 minus 8. So that's plus 40 equals 180. So I'm going to subtract 40. That's going to give me 64x equals 140. And then I'm going to divide by 64. Now, something's telling me we might get a decimal here again, but that's fine. Don't be alarmed. Let's see what happens here. Whoa, 2.1875. Now, listen, that's not an infinite decimal. That doesn't go on forever. I'm actually going to leave all of those decimals there for right now. 2.1875. Leave it there, okay? If you round it, you'll be close, all right? If you round it, you'll be close. But I want to try to be as accurate and exact as possible. So now what I'm going to do is I'm going to take that decimal and I'm going to plug it into each of these spots, okay? So let's start with the 16x plus 24. 16 times, and I'm going to copy the whole thing, 2.1875, okay, and then plus 24. Oh, not bad. It actually works out to a nice whole number. So at this point in time, I believe that angle D is 59 degrees, which at the same time, I come over here, I believe angle B is 59 degrees. But I want to test it. I want to make sure that I'm correct. Okay, so now what I'm going to do is take 32x minus 8, and I'm going to substitute the decimal in for that. Okay, I'm going to clear that out. Whoops, excuse me. All right, so 32 times 2.1875 minus 8, and we're getting 62 degrees. Wow, that actually worked out nicely. Even though it's a messy decimal, we are getting 59, 59, 62. It's actually pretty close to an equilateral triangle, but not so much. All right, so this would be, what would this be, guys? I think this would be an acute isosceles triangle. All right, we're almost done. We got 2 more parts here. Part B. Very similar, same diagram, same directions up top, but now they're giving us some side lengths. AB is 12y minus 10. AD is 7y plus 40. And now BD is 20y. Okay. So guys, once again, I'm going to mark this diagram the way we should every time. These are my equal legs. BD is the base. So those are my equal base angles. Now, again, I said this in the last video. Some students will be tempted to add all three of these up. In the previous example, guys, that's what we did. We added all three angles together. But that's angle measures. We know that the angles add up to 180 degrees. Guys, if you add up three sides of a triangle, that's perimeter. Perimeter is not restricted to anything. You could have small triangles, large triangles, huge triangles. If you add up the side lengths, it could be any positive number, not 180. So we're going to stick to the game plan like we did before with the circles. I'm going to take what I know. I'm going to temporarily ignore 20y. I know that these are the equal legs, so those are the two I'm going to use. So I'm going to have 12y minus 10 equals 7y plus 40. Okay. Now, guys, we're right back to an algebraic equation. We're going to solve this, so I'm going to add 10 over. So that's 12y equals 7y plus 50. I'm going to subtract 7y to the left. That's going to work out nicely. 5y equals 50, thus y equals 10. Okay. So I think y equals 10. Let's see what happens when we substitute it in. So that's going to give us 10 times 12. That's 120 minus 10 is going to give us 110. Guys, not degrees. 110 units. I'm going to abbreviate there. Okay. Over here on the other side, 10 times 7 is 70 plus 40. Oh, we're liking that. They're equal. We got 110 units. So this side is 110. This side is 110. Let's see what we get over here. All right, 20 times 10. That should work out nicely. That's 200 units long. Okay, so this worked out. Finally, down the bottom, is triangle BAD also an equilateral triangle? No, absolutely not. We could say very simply, not all three sides are equal, and likewise, all three angles aren't the same. All right, so that should do it, ladies and gentlemen. Those are a couple videos to help you out with your algebra. Let us know if you need any questions answered. Come meet us. We'll talk to you soon. Thanks. Bye.